Hi students, for today's video, we're going to look into the naming of organic molecule using IUPAC system. Right, this topic is picked as part of your revision because many students feedback that they find it very complicated when they are given an organic molecule and they are asked to name it using the IUPAC nomenclature. So let's start today's lesson. Right, so whenever you are asked to name an organic molecule, always remember you need to first analyze the molecule first before you move on to the specific naming. And when I talk about analyze, what I mean is that you have to first figure out which is the longest chain of that molecule and decide which is the direction that you need to read the molecule. All right. Now, until this point, some of you might have a question. What do you mean by longest chain? So when we talk about the longest chain, it means to say the direction that covers most carbon, right? The longest chain of an organic molecule is always a direction or a site that covers most carbon, right? Now, then the next question would be, how do I know how to find the longest chain of the molecule? Now, in order for you to figure out the longest chain of an organic molecule, you always have to do trial and error, right? And these are the suggestions how you can identify your longest chain. Number one, you can try to read your molecule from left to right, all right? I will name it as direction A, easier for me to discuss later. You can name it from, you can do it from left to right in a linear form, or another option for you to find your longest chain is that you can again go for direction A, left to right, call it direction A, and you try to read it in L shape, all right? Or third option, you can read from another direction, which is from right back to left. And in short, we call it direction B, all right? You can do it in linear form, all right? As well as the last option, you can do from right to left, or in short, we call it direction B in L shape. So if you do try and error according to these 4 points, you will be able to see your longest chain easily, right? Okay, that's one. Now, the next thing that you need to understand is that whenever you have whenever you've got a molecule that has functional group, right? Please always make sure that the functional group is part of the longest chain, all right? So you need this one. So remember, to identify your longest chain, you can either go for direction A. So when I mention direction A means left to right. You can go direction A, linear, or direction A, L shape. Or you can go direction B, which is from right back to left, direction B, linear, or direction B, L shape. All right, but please make sure that for the molecule that has functional group has to be part of the longest chain. Okay, all right, so with this idea, we are now able to look into a real example. How do I read a molecule? Now, for example, let's look at this particular image over here. You're given an organic molecule. So again, before I can even name it, I need to decide where is the longest chain and how should I read my molecule. All right, so again, there are 4 ways for you to read. You can either go for direction A, means you go for this direction. If you go for direction A, linear, you manage to see that you are covering 4 carbon and your functional group, which is the double bond, starts at position 1. Next, I can also read from direction. So this is direction A. I can go for direction A. If I go L shape, how does it look like? If I go for L shape, I managed to cover 1, 2, 3, 4, 5 carbon, and my functional group starts at position 1. So from here, from this direction, you can, up to here, you will see that direction A, L shape will give you more carbon, will cover more carbon compared to the linear style. All right. Now, how about now if I try to read from direction B? So direction B means you try to read from here. Okay, so this is direction B. So if I read from here in a linear way, I'll be reading it this way. And my double bond, it's only starting at position number 3. 4 carbon, double bond position number 3. Now, if I read it in L shape, what I managed to see is that I'll be able to cover 1, 2, 3, 1, 2, 3, 4, 4 carbon also. 4 carbon also. Now from here, what you can see is that I can safely decide that the longest chain has to be read from direction A in L shape, because only direction A in L shape covers most carbon, which is 5 carbon. The other side of reading, maximum only they can cover 4 carbon. All right, so therefore for this molecule, I'll be reading it from direction A in the L shape. So that's my longest chain. Okay, so we go for more example. Let's look at the second one. Okay, if I were to read this molecule, so again, the options would be, I can read from direction A. All right, this is direction A. And because this is a linear molecule, you can only read it linearly. Right, so if I read from direction A linear, I will cover 4 carbon and my double bond starts at position 1. But if I read it from direction B, right, so if I read it from direction B, I also cover 4 carbon, but however, my functional group, the double bond, only starts at position 3. So both direction, when you read it linearly, they give you the same number of maximum number of carbon, which is 4 carbon. But if you read from direction A, your double bond, it's found in the front part of the molecule. If you read from B, your double bond is found in the back part of the molecule. You are supposed to give priority for the one that gives you a more front part of the functional group. So in this case, I will pick position A, because not just that it covers 4 carbon, but it gives me a more front position of my functional group. All right. Okay, so we do one more example. Let's look at this molecule. Again, I need to find out what's my longest chain and how should I read it. If I read it from direction A, right, linearly, I will cover 4 carbon. Double bond starts at position 1. If I read it in L shape, I will only cover 3 carbon. And my double bond is in the first position. So in this case, you know that this option will not give you the longest chain. Right. Now, how about the other one? Now, let's try if I read it from position B. If I read it from position B, linearly, I will cover 4 carbon, but my functional group is found at the back of the molecule, which is not so advisable compared to direction A. So this is not so good. Now, how about if I go direction B in L shape? If I go in L shape, I can cover 1, 2, 3, 4 carbon, but however, it doesn't include my functional. It doesn't include my functional group. Remember just now I mentioned that whenever you define and find out the longest chain, you make sure that the functional group is part of it. So therefore, this is also out. So at the end of the day, this molecule should be read from direction A in a linear position, right? So that would be your longest chain. So this one is your longest chain. Okay, so with here, I hope that you now be able to see how can you decide the longest chain of the molecule and how you should read your molecule. Is it from direction A or is it from direction B? Is it linear or is it L-shaped? All right, okay, so to continue on, now I will do another sharing. So I will be doing the sharing using the Word document. All right, so with the whiteboard just now, I've taught you how to look into the longest chain of the molecule and how do you decide the direction, how do you read the molecule. Now the next thing is we'll be looking into specific example. How do we name the molecule using the IUPAC naming system? Now always remember, whenever you need to name a normal organic molecule, all right, your name should have these three compositions inside. The naming of normal organic molecule should start with the position of branch, right? Then following by mentioning the name of branch. Now, a lot of students will ask me, how do we actually know the name of branch? The name of branch is depending on the number of carbon that it contains. If your branch contains 1 carbon, we will normally call that branch as the methyl branch. If your branch has 2 carbon, we call that as the ethyl branch, so on and so forth, right? So once you have named the branch, the last thing is you will name for alkanes, the first homologous series, you will name the longest chain. But for all other organic compound that has a functional group, you need to name the longest chain together with the position of functional group. Now, what do I mean by this? So next we'll be looking into the 6th example of normal organic molecule and how we should read it. Okay, so let's start off with the first one. So always remember, before you name it, you need to decide where is your longest chain and how you're going to read your molecule. So again, if I want to find out the longest chain, I will start by asking myself, if I go position A and linear, position A means from here, linear, I will cover 1, 2, 3, 4, 5 carbon. If I go A, L shape, I only cover 3. How about if I go from B? For direction B, linear, you cover 4 carbon. And direction B, if you go, if you go L shape, you cover 5 carbon. That means to say, whichever direction that you choose, the maximum carbon that you manage to cover is 5 carbon. All right, and you can get that from either reading from direction A, linear, or you can get it from direction B, linear as well. Direction B, linear. All right, you can also get 5 carbon. You will also get 5 carbon if you read from direction B, L shape. So now, since all three options will give you the same maximum number of carbon, right? So at the end of the day, which one should I choose? Which one you should choose? Now, if your molecule has a functional group, you choose the direction that's closest to your functional group. But however, like in this molecule, there's no functional group, right? You choose the site that's closest to the branch, That means to say, 5 carbon is over here. If I read from direction A, this is my longest chain, and my branch is at position 2. If I read from direction B, linear, this way, my longest chain has 5 carbon, and my branch is only at position number 4. So therefore, direction B is not a good option because my branch is quite far away. Now, how about if I go L shape? If I go L shape, this is my longest chain. Anything outside is my branch. So your branch is at position 2, which is the same as direction A, linear. So in this case, you can choose either one to read your molecule. So for me, I will prefer direction A, linear. Okay, so with that, I'll be reading my molecule from this direction. This is my longest chain. Right, so this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And whichever carbon that's outside of it, this is the branch. All right. Okay, so with that, let's do the naming together. First, we start by naming the position of branch. Right? So my branch it's found at, because I name it, I read my longest chain in direction A. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So my branch is positioned at number 2. Next, name of branch. I will ask myself, this branch has how many carbon? It has 1 carbon. So the name of this branch is called the methyl branch. Last but not least, we are looking at a normal alkanes molecule. We now need to name the longest chain. So when you look at this one, my longest chain has 5 carbon here. So a 5 carbon alkane has the name of pentane. So this is the name of this organic molecule following the IUPAC system, right? Now, for those who still find it a little bit more confused, let's look at the next example. So again, the next example, we have it over here. So I need to first analyze where's my longest chain. Direction A, linear, 4 carbon. Direction A, L shape, you can only get 3 carbon, right? Direction B, linear, 4 carbon. L shape, also 4 carbon. So which is the better one? All right. So let's do a writing over here. So for this one, maximum, I can cover 4 carbon. I can do it with direction A, linear, or I can get it from direction B, linear. I can also get it when I go direction B, L shape. Okay, so to decide further, we have to pick the one that is closest to our branch. If I go for direction A, both branches is at position 2. Branches at position 2. Right? Now, how about if I go for direction B? If I go for direction B, linear, right, which is this way, both branches are at position 3. So both branches are at position 3. Next, if I go L shape, over here, L shape, whether you go L up or L down, you will realize that your branches, which is anything outside, your branches is at position 2 as well. Right, so because if you go L shape over here, this is your branch at position 2, this is your branch at position 2 as well. So if that's the case, direction B, linear, is definitely out. Next, between direction A, linear, and direction B, L shape, you can choose either one. So for me, to make my life easier, I will normally go for the linear ones. Okay, so which means to say, for this particular molecule, I'm going to read it here. I'm going to read it from direction A, which is over here, and this is, I will read it linearly. So this is how I'm going to read it: carbon 1, carbon 2, carbon 3, carbon 4. And whichever carbon that is out of it, outside of the longest chain, that is called the branch. So you have the branch is up, and then you have another branch that is down. Okay, so once you're able to analyze this, the next thing is you should be able to name it. So again, to name it, you always start with the position of branch. So in this case, since I have 2 branches with me, so I need to tell the position of both branches. So branch 1 is positioned at number 2. It's positioned at carbon number 2. Now how about branch 2? Branch 2 is also attached to carbon number 2. So the position is also 2. Right. Next, what is the name of my branch? My branch 1 has 1 carbon, so branch 1 is a methyl branch. My branch 2 also has 1 carbon. It is also a methyl branch. So therefore, I have methyl branch, and I have 2 of them, dimethyl branch. Right? Remember, this is not an ethyl branch because your branch 1 has 1 carbon, is 1 methyl, Branch 2 also has one carbon, another methyl. So you have a dimethyl branch over here. All right. So now looking into this molecule is just a normal alkane. So we need to just name the longest chain. Now my longest chain, which is being boxed out, has 4 carbon. So I call it the butane. All right. Alkane with 4 carbon is called butane. Okay. So that is molecule number 2. All right. Next, moving on. How about the third one? Look at the third one. So again, before I decide how to name it, I have to find out where is my longest chain. If I read from direction A linearly, I cover 1, 2, 3, 4, 5 carbon, and my double bond starts at position 1. If I go L-shape, I only cover 3, so that one definitely cannot be part of the longest chain. Now, how about if I read from direction B over here? I also cover 5 carbon, but the functional group is quite far away. And again, if I read L-shape from direction B, if I go L-shape, yes, it covers 5 carbon, but there's no functional group being included. So that is not a good option. So with that, I've made a decision. My longest chain should be read from, my longest chain should be read from direction A. Direction A, all right? And linearly, I will read it. So therefore, when I read this molecule, this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. And whichever carbon that's out of it, that one will be the branch. So this is the branch. Okay, next, we have to name it. To name this molecule, again, we start by naming the position of branch. So my branch is attached at position 2. This is 2 dash. All right, next, what's the name of this branch? This branch has 1 carbon. This is called a methyl branch. Next, now when I look at this molecule, right, this is no longer alkane because it has a functional group of double bond. So when I name the last element, I will have to name the longest chain with the position of functional group. All right, so what do I mean by this is that when I look at this molecule, this longest chain that I have picked has 5 carbon. So 5 carbon with a double bond is called pentene. Right, not 5 carbon with a double bond, it is called pentene. But however, the word pentene itself only shows the number of carbon in the longest chain. It doesn't show the position of the functional group, right? So your functional group is your double bond, is your in. You have to be more specific by telling people where is your in, where is your double bond. Now over here, this is how I modify my answer. When I look back at my molecule, my in, my double bond starts at position 1. Therefore, I will modify the answer by putting a space in between. I put a dash, and I put a 1 dash in. So this one, so just now it was pentene. So when you read the word pentene, means you understand there's 5 carbon and there's a double bond, but you do not know where's the double bond. So if you want to tell people where is the double bond, where is your functional group, what you need to do is you just add a figure. You just add the suitable figure in front of the name of your homologous series. My homologous series is alkene, so it's called in. My in is at position 1. So this 1 represents the position of your functional group. All right, so this is the name for the third molecule. Now we do one more example. Let's look at the next one. All right, so again, if I want to read the molecule, I need to decide, am I going to read from A linear, A L shape, or B linear, B L shape? If I read from A linear, I cover 1, 2, 3, 4, 5 carbon. If I go for L shape, I can only cover 3 carbon or maximum 4 carbon. So L shape is not applicable. How about from direction B? If I go for direction B linear, I cover 5 carbon. If I go for L shape, I cover 4 and I cover 5 carbon. So to analyze this, we put a note at the side. So for this one, I can go linear A, linear direction A. If I go like this, I have 5 carbon and my double bond, which is my functional group, at position 2, starts at carbon number 2. Okay, how about if I go linear B? Linear B also I managed to cover 5 carbon, double bond. So if you go 5 carbon, double bond at position 3, all right? And if I go L shape B, the longest that I can stretch is over here, 5 carbon, and my double bond at, so if I go L shape, the longest L shape is over here, double bond at position 2. So if I go over here, 1, 2, 3, position 3. So in this case, I think the best one to choose is linear from direction A. So you will read it linearly from direction A. Okay, so this is that decision that I've made. Linear direction A. So over here, I put. Okay, so now my longest chain is over here, linear, and now we'll read it from direction A. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and whichever carbon is outside of it, that is my branch. So I have a branch here, I have another branch over here. Okay, so now to name this molecule, we start with the position of branch. So you have branch 1 at position 2, branch 2 at position 3. So the first one at position 2, the next one at position 3. Okay, what's the name of my branch? My first branch is a methyl branch. My second branch is also a methyl branch. So in this case, I have 2 methyl branch. Right, next. What's the name of my longest chain? My longest chain has 5 carbon with double bond. So if you remember, 5 carbon is pent, and because it has a double bond, it's called pentene. But again, however, according to the rule, you don't just name the longest chain, you must also tell people where is your functional group. In this case, it's the double bond. So where is my double bond? Where is my in? My double bond or my in started from position number 2. So therefore, I will extend the name a bit, I will modify the name a bit, I put a space between them, I show them that my in is at position number 2. All right, so it's called pen 2 in. All right, the 2 over here shows you the position of the double bond. Now at this moment, some students might confuse, why is it there's figure in front of the name and there's a figure behind in the middle of the name. Now remember, the figure in front of all the names, right, refers to the position of branch. And the figure at the back of the name refers to the position of the functional group. All right. Okay, so next we look at this molecule. All right, if you want to name it, let's again analyze it. Direction A, linear, 4 carbon, but double bond is only at position 3. If you go L shape, maximum you only get 3 carbon. So L shape is out for direction A. Direction B, if you go linear, you cover 1, 2, 3, 4, 4 carbon. And double bond is at position 1. If you go L shape also, you cover 4 carbon, double bond is position 1. So in that case, I will make a decision. I'm going to read from direction B and I will go it linearly. Because whether L shape or linear, since they give you the same number of carbon and the same position of double bond, I would normally prefer to read from linearly. It's easier for me. Okay, so therefore, if I read from B, this is carbon 1, carbon 2, carbon 3, carbon 4. Any carbon that's outside of it is called a branch. So here, this is a branch as well. Okay, so now let's name the molecule. We start with the name of the position of the branch. First branch, So if I read from here, the first branch is position 3. Second branch is also at position 3. Next, what's the name of the branch? My first branch is called a methyl branch. My second branch is also called a methyl branch. So this is dimethyl, right? Last but not least, the ending name. My longest chain has 4 carbon with a double bond. If you go 4 carbon with a double bond, you will end it with butene, right? But again, because you have a functional group, you need to modify this name by telling us where is your in, where is your double bond. So to do this, I will make a space in between. Now I'll ask myself, according to my reading from direction B linearly, my double bond starts at position 1. So my in begins at position 1. All right? So this is 1 to show the position of my double bond. Okay, right. Now we look at the last example over here. So again, when you look at this molecule, yes, it has a functional group, which is OH. So now how do I read it? From direction A, linear, 4 carbon. L shape, 4 carbon, and there's no functional group. So it's definitely out. How about if I go from B, linear, 4 carbon. If I go L shape, 1, 2, 3, 4, 5. I believe with this, all of you would agree with me that in this case, I'm going to read from direction B in L shape. Because if I do it in L shape, I will be able to get the most carbon, which is 5 carbon, right over here. So therefore, you have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And again, whichever carbon that's outside of the longest chain, that is your branch, right? So now let's name this molecule. Right, start with the position of branch, position 1, position 2, position 3. So 3 dash. What's the name of this branch? Again, this branch only has 1 carbon, all right? So it's called the methyl branch. Right? Now, what's left in my longest chain? My longest chain has 5 carbon with OH. OH means all. So that means to say this is actually a pentanol. But again, you do not leave your answer here because you need to tell me pentanol only suggests that it is an alcohol with 5 carbon. But you need to tell me where is the functional group? Where is your O? Where is your OH? Your OH is positioned at number 2. So I need to modify this name, right? I will be modifying this name. Okay, how? So I will separate out the O. So I need to tell people where's my O. O means OH. My OH is at position number 2. All right? So the 2 over here suggests the position of my functional group. That's O. Okay, so with that, I hope you guys can roughly understand how to do a quick naming of organic molecule using the IUPAC system. All right, now in certain situation, you might be given a organic molecule that has some special group inside. So a key idea for, if you're given an organic molecule with special group, when you name it, right, you basically follow the same concept, but you modify it a bit. You will first tell us the position of that special group. And when we talk about special group means we refer to things like Cl or Br that's being added in. All right, so you first tell us the position of the special group, what's the name of that special group, and again, the name of the longest chain. Right, so example would be this one. Okay, let's look at this example. So for this example, this is an organic molecule. Again, to name it, you have to identify where's your longest chain. I believe you can see it straight away. I will go for direction A linearly because it covers 4 carbon. All right. Some will say, teacher, B also can go what? If I go, so this is the direction that I choose. I will read from A and I will go it linearly. Now, some of you might wonder, how about if I read from B linearly? I also cover 4 carbon. Now, in that case, if you have both directions that give you the same maximum number of carbon, please choose the one where it's closest to a branch or where it's closest to a function, a special group, functional group and special group. So in this case, you can see if I read from direction A, my special group, which is this one, this is not a branch, this is chlorine, this is a special group. So if I read from A, my special group is at position 2. If I read from B, is further away, it's position 3. So we will go for the one that gave us the closer position of branch or special group or functional group. Okay, right. So in that case, this is how do I name it? As usual, start with the position of your special group. Over here, my special group is chlorine, right? It's located at position 2. And what's the name of this special group? It's called chloro group. Then in your longest chain, I have 4 carbon and all bonded by single bond. So we call it as the butane. So that's the name of this special molecule. Okay, one more example. How about this? When I look at this example, again, I will decide that this is my longest chain, right? And in this case, whether I read from direction A or direction B, it's the same because both directions cover the same maximum 4 carbon. If I read from A, my special group is at position 2 and position 3. If I read from B, my special group is also at position 2 or 3. So in this case, whether you read from A or B, it's going to give you the same result. Okay, so now, so my special group, again, these are not branches. Branches means carbon branch. These are special group. Okay, now to name it, start with the position of my special group. First special group is located at position 2. Second special group is at position 3. What's the name of this group? Bromine, right? When you put it in a molecule, it's called bromo, right? And in this case, I have 2 bromo groups, so it's dibromo. And my longest chain has 4 carbon and all single bond, so it's called butane, right? So hope with this you can have a better idea on the naming of organic molecule using normal IUPAC nomenclature. All right, thank you.